Let's get started. We reviewed some algebra topics yesterday. We're going to continue with those algebra topics today. There's not as many to finish. We did all of these yesterday, with the exception of number 9. So we just did some multi-step equations. We FOILed or box method, whichever one you prefer. And now we're getting back into a little bit of factoring. So that is kind of where we will pick up. I think I'm just going to pick up from number 15, because number 14 is really just like the previous ones. They just throw a little bit of a harder number at you, but feel free to do it on your own. I've never seen Mulan either, so I have no idea what you're talking about. It's alright, Gavin, I'm with you. There is going to be a new method. I'm pretty sure you've never learned it. It's not going to come up very frequently. It is rarely it would ever come up in geometry, but I know it is something you will be learning next year in Algebra 2, which is why I have number 18 circled. I don't know why I have 16 circled. We do have to kind of take a look at examples when the A term is not 1. So if you notice in all the factoring we've done so far, 11, 12, 13, and if we had done 14, the number in front of the x is always a 1. That's important when we're factoring. It makes this traditional method of factoring, fine. We can always do it. But as soon as there's another number in front of there, like you're going to see in number 18, that is going to change a bit, as well as number 17 too. And there's kind of two different things that we can do. Some works sometimes. Actually, they both only work some of the time. So it's really going to matter how we're going to use it. We'll do 15 and 16. First, though, actually, I think these ones are some of the easiest ones to factor. So this kind of goes back to a rule you might remember from last year, which is difference of squares. So difference of squares is one of the easiest ways of factoring. You're not going to use that traditional A-B method, two numbers that multiply into 64, add or subtract into the B term. We don't have a B term. I mean, we technically could call the B term 0, but we don't need to do that. We can do something far easier. You'll notice a few things here. It's called difference of squares because, one, it has to be subtraction. This does not work if there's addition in the middle. Keep that in mind. If this were x squared plus 64, would not work. So that's why it's called difference of squares. It's not difference or addition of squares, just difference. So it has to be subtraction. And it says squares if the two terms, if this is a perfect square and this is a perfect square, you can factor right away. No, the weekly is due on Friday. X squared and 64 are perfect squares. When you square root both of them, the square root of x squared is x, and the square root of 64 is 8. So you can jump right into your double parentheses. You're going to put an x and an 8, an x and an 8. One is plus, one is minus. Doesn't matter which one. And that's difference of squares. It's very, very easy. It is that straightforward, and it works every single time. As long as those are perfect squares. If it were x squared minus 50, well, that's not going to factor as nicely because 50 is not a perfect square. All right. I apologize for that. I had a phone call I had to cancel. All right, 9x squared minus 1. Same thing. There's a minus sign. It's two terms. Are they perfect squares? 9x squared has two things with it. It has a coefficient and then the x squared, but they're both perfect squares because the square root of 9 is 3 and the square root of x squared is x. So the square root of this thing is just 3x. And 1 is a perfect square. The square root of 1 is itself 1. So we can jump right into our double parentheses. 3x and 1, 3x and 1, 1 minus, 1 plus, and that's it. Number 17. Now this is where we need to be mindful of the a term. There's an a term, so we need to keep in mind that we cannot factor in a traditional sense. You can't do two numbers that are going to multiply into the 80, add into the 4, when that a term is not a 1. So first and foremost, if you ever see an a term in front of the x, see if you can factor it out or get rid of it in some way. And I noticed that every term does in fact have a factor of 4. Because it has a factor of 4, I can factor out that 4 right off the bat. So when you factor 4 out of every term, you're left with x squared plus x, and you factor 4 out of 80, you get 20. But now you just have this 4 outside of parentheses, and you do need to have parentheses around everything right now. So this is something we can absolutely factor, and we can just ignore the 4. We just need to keep that 4 on the outside, basically. But now I can just factor this part I have highlighted like we normally have done. So it's 4 times. I'll open up my double parentheses. Let's figure out our addition and multiplication off to the side over here. So two numbers that multiply into 20, two numbers that are going to add into its 1x. And I did mention yesterday, based on the signs, it's plus minus. So it is going to be two different signs. The bigger one is going to be positive because this plus comes first. The smaller number will be negative. In this case, it is, I think it's 5 and negative 4. Just double check that, make sure that works. Correct. There's no regions for any class. You think we'll be going back? I'm not so sure. I think we'll have a decision this week, but I don't know. But those are my factors right there. X plus 5 and x minus 4. We should get information this week about going back. The governor is making some sort of decision whether we will return or extend. Oh. All right. Number 18. Now, number 18 is going to be something completely different. Like I said, this has all been review. This one I think is going to be new. I'm unsure if you've ever been able to factor something like this. So I am going to show us something brand new, which is going to be very useful to you next year in Algebra 2. So you can keep that in mind if you're able to remember this method. We're not going to practice it a whole bunch though, but I am going to show it to you. That way you can utilize it next year, because it will come up in 18, and I think we can try it in number 24 as well. So that's really the only time we're ever going to see it, but I think it's a really useful trick that helps you factor out a lot. Some students like this method a lot because otherwise you have really no good way of factoring this term right here. And it's all because of the 2. And unlike the other one, well, can we factor out the 2? Well, we could. The 28 and the 2x can factor out a 2, but you can't factor a 2 out of this because it's a 1, and you'd be left with 1/2, and we want to avoid fractions or decimals. So what do? Now I'm stuck with an a term, and I'm forced to now factor with an a term. Well, we have a solution. So you can't factor like normal, so we're going to go to what is called the AC method. Like I said, this is a very useful trick. Might be a little confusing as well. I think it gets easier with practice, so definitely try to follow along in this example. So it's called the AC method and this is a trick for factoring. And this is how the trick works. You're going to take the A term, the 2. You're going to multiply it into this C term. So it becomes x squared minus x. And then it's 2 times the 28, which is negative 56. I'm not sure if you did this exactly in algebra, because I think I do it a little differently than you might have learned. And I find that students like this way better because it is technically, I think, easier. Just notice we've done something algebraically illegal. We can't just multiply that by 2 because we've ignored this. This is, for all intents and purposes, a mathematical trick that just happens to work, which is kind of nice. And there's reasons why it works. I'm not going to get into the reasons, but we could really dig down into why this works the way it does. But that's how it starts off. So this is why it's called the AC method. I took the A term, the 2, multiplied it completely into the C term. Then what I do from here is I factor like normal. So we're just going to factor like normal. 2 numbers that multiply into negative 56. And then 2 numbers that add into, is that negative 1? So what do we have here? I think it's 8 and 7. 8 and 7. One of them has to be negative, and because the negative comes first, it's negative, negative. The bigger number is negative, so it's negative 8 and 7. And that looks good. So I'm going to, over here. Well, we're not done. Because remember at the beginning of the problem, I established that I was doing what is called the AC method. So this was not the original function. And that's what I factored. So we still have to kind of bring that trick back. And I remember, what number did I multiply in the beginning with? Whatever you multiplied, you're going to take the C term, which was 2. So we're going to take this 2, and you're going to divide both of these by 2. And this is where it gets a little strange, if it hasn't been strange already. So look at the numbers that I put over 2. If it divides or reduces, do so. Which in the 8 divided by 2 does work. Because it works, I just reduce and divide like normally. So it's x minus 4. This one does not work. 7 does not divide into 2 evenly. So the trick is, you're going to just take that 2, and you're going to move it right in front of the x, and you're left with 2x plus 7. And again, it's a little mathematical trick for factoring, but that is how we do it. It's really just 2 extra steps. Take the A term, multiply in the C term, which is why it's called the AC method. And then at the very end, whatever you had as your C term, which was right here, you divide both of them. If it reduces, great. If it doesn't, you just throw the coefficient in front. So I'm assuming that is something completely new. And I know that's new, and that would probably require some practice to really memorize it and get it and know how to do it. We're only gonna, because it's geometry, it's not an Algebra 2 course. I'm just kind of exposing it to you. Feel free to use it next year. I think it's a really good, useful way of factoring. For anyone who plans on moving on to calculus, I will use this method all the time whenever it comes up. And it's useful whenever that A term is something other than 1. Alright? So I wanted to make sure I spent some time explaining that one. Alright, let's go down. Now we'll go into quadratic equations. Which for quadratic equations, few options you can do. Your first strategy should always be, can I factor my quadratic? Most of the time you might be able to. If you ever come into a situation where you cannot factor, the one method that will always work no matter what, even if it factors or doesn't factor or whatever, the method that would work is your quadratic formula. Your negative b plus or minus the square root of b squared minus 4ac all over 2a. That will always work if you ever forget about factoring. And that's what makes this very useful. Say you come into a situation like number 18 and you forgot how to factor. Well, it's okay. If you forgot how to factor, you have the one method that will truly always work, the quadratic equation. It just happens to be when you get really good with these factoring methods, problems go much faster, they're much easier, and I think you'll have a better understanding of the mathematics. So the first thing is, let's see if we can factor number 19, which I'm pretty sure it does. One thing that I notice, the signs are minus plus. When the signs are minus plus, both numbers are going to be negative. It just happens to always work out that way. So two numbers that are going to multiply into positive 20 that are both negative, and then two negative numbers that add into negative 9. I think this one's pretty easy. Negative 4 and negative 5. And they are both negative. They multiply into positive 20. They add to negative 9. But now it's set equal to 0, because all the other problems we had, there was no equal signs. But now they're equal to 0, so I make sure I write equals 0, and we just have one additional step, solve. Which, what this means is, if this term were 0, the whole thing is 0. So you can separate it. I'm not sure how Ms. Chambers did it with you guys last year. You could write it like this. Each factor, you can now set equal to 0, and then just solve from there, which is easy. Add 4 to both sides. You get x is equal to 4. And then for this one, x is equal to 5. You'll notice for the most part, the signs just got flipped. That's it. Which is most of the time what just happens. That should be nothing new. That should be something that you have done a whole bunch of times last year in algebra. Okay? Then we get to number 20. The only problem with number 20 is you can't just jump in and start factoring. You might want to and find numbers that multiply into 135. One thing that has to be true whenever you're solving quadratics, which is different from pretty much every other equation you've ever done, is the equation needs to be set equal to 0 rather than, you don't get x squared by itself because you have two x terms. You have an x squared and this x term. So the trick is get everything on one side. So you actually have to subtract 135 first before you do anything. So you have x squared plus 6x minus 135 is equal to 0. Then we're going to factor this. So two numbers that are going to multiply into negative 135, but add into 6. Let's see, what are those two numbers? Let's see, I'm going to start dividing 135 by some values, because again, I don't know this one. First number I tried was 15, and I think I got it in one shot. Sometimes you can predict these numbers pretty easily if you know what they're divisible by. You know it would be divisible by 5. But I divided it by 15, and I got 9. So I think those are my two, 15 and 9. The 9 would be negative. So x plus 15, x minus 9, and then you're going to solve each of them. If you do not want to write this out, x plus 15 equals 0, x minus 9 equals 0, I'm fine with that. I want to see that you factored it, and then after you factored it, you can then solve it. I do want to see this step at least. But if you don't want to write the x plus 15 equals 0, the x minus 9 equals 0, and you want to jump right into x equals negative 15 and x equals positive 9, go for it. You do get multiple answers, obviously, but it would look like that. So number 21, same thing, solve for x. Now, one other thing that, we didn't really consider with the last one, make sure your x squared is your positive term. It doesn't matter if it's on the left-hand side or right-hand side. It's always better if it's positive, because if it's negative, you may not want to factor it like usual. You might have to kind of flip the signs or something. But because the x squared is right there, I'm going to bring this x over here, which you are going to have to combine like terms. You have now, you're subtracting an x, and there's an x term already over there. So it's going to be negative 9x minus x, which is minus 10x. And then you're going to have to subtract 24 from both sides, because you need the whole equation, set equal to 0. And then we can factor from here. I'm just going to factor a little bit quicker. I think it's 6 and 4. Just double checking, make sure that is right. No, that's not right, right? It's got to be 12 and 2. My apologies. That's right. If you're able to FOIL, and you can kind of, go backwards and make sure you get back to the same thing, you should. That's how I was able to tell that, 6 and 4 does not work. Because 6 plus 4 does add up to 10, but the way I had it written out, it actually would not work. So 10 and 24 can be a little bit tricky. But then from here, x equals 12, x equals negative 2. Sorry. Yeah, x equals 12 and x equals negative 2. I think number 22 becomes pretty much the same, so I think I'm just going to skip that one. 23 is pretty good, though. There's a few things you could do with 23. Because it's sort of factored already, right? It's sort of factored. You have x plus 1 times x minus 4. The left-hand side is factored, but it's not equal to 0. It's equal to 6. Which is fine, but instead of doing each term, you could do x plus 1 and just set it equal to 6. Because it's technically already factored, but just make sure you set it equal to 6 rather than setting it equal to 0. So that's something we are allowed to do in that case. And then you can do x minus 4 is also equal to 6. And then solve these. Minus 1 from both sides. You got x equals 5. And then you're going to add 4 to both sides. And you got as x is equal to 10. Sounds a little bit different, but that is something that we are allowed to do. The other way you could do it is you could do your box method, then subtract that 6 from both sides, and then just redo the, then go factor back, and you'd likely get 5 and 10 and whatnot. And I like 24 because 24 has that a term as a 2. So this is going to force us to use the new AC method that we just did earlier in class. So we're going to use this method, but we're just going to take it one step further and solve. So let's see if we can kind of work out this method. First thing, set it equal to 0. So 2x squared, subtract 3x from both sides. So you get minus 3x. You're also going to subtract 9 from both sides. Then strategy number 1, not going to work because your a term is not a 1. So you can't just factor like normal. You can't find two numbers that multiply into negative 9, add to the negative 3 right now. Even though they might find two numbers, which I think would be like 3 and 3. No, maybe not. But Doesn't matter. Your a term is not a 1. Then you want to see, can you factor it out right now? Can you factor out a 2 from every term? No, because you can't factor out a 2 from 3 and 9. So then you go to method number 3, which is the AC method. And there's also a chance that the AC method doesn't work, because if it doesn't, you go to method number 4, which is the quadratic formula. So if you remember the AC method, which we just did a few moments ago, what if there was a situation where the squared x was negative? Is that possible? Yes. I'll get to that question in just a second. So what I'll do is I'll take a look at 22 and I'll just throw a negative in front of it. And yeah, that's one thing. You can move it to the other side. You could also flip the sign of everything. I'll show you what I mean. But I'll finish 24 first. So I'm going to go through my AC method. 2 times negative 9, first step. So 2x squared. Leave the b term. Multiply the c term. Whoops. You don't rewrite the a term because that's now multiplied out. But remember, we are doing the AC method, so we're going to have to do that weird step towards the end. Okay? So we got a factor like normal. So we get x. 2 numbers that multiply into negative 18 and then add into negative 3. I think it's 6 and 3. Minus, plus. But before you solve now, because now you might be inclined to, let me add 6 to both sides, subtract 3, whatever. We're still doing the AC method. And remember, once you factor like normal, now it's time to divide by whatever we multiplied in the beginning by. The C term in this case was 2 again. So we're going to divide by 2. And look at them individually. Does 6 divide into 2? Yes, it does. It's 3. So I just do x minus 3. But does 3 divide into 2? It does not. And because it doesn't, the trick is you just take the 2 and you throw it in front of the x. Again, I know it's a little strange algebraic maneuver, but it always works. It's a really cool method, I think. So you're left with 2x plus 3. And you only do that when you cannot divide normally. And we're going to set that equal to 0. Then we can solve like normal. One of them is a little tricky, one of them is not, because one of them is going to be a decimal, because one is x minus 3 equals 0. The other is 2x plus 3 equals 0. So one of the answers is x equals 3. The other one, you're going to have to subtract both sides by 3. So it's 2x equals negative 3. And then divide by 2. So x equals negative 3/2. I'm going to go back to some of these questions because I've seen in chat some people talking about negative x squareds and whatnot. And they're all really good points to bring up. When you have a negative in front of your x squared, so I'm just going to take this one for example. I'm going to call this negative x squared plus 12x. I'm changing it a little bit. Minus 36 equals 0. So I know I changed it a bit. If this were your quadratic, and Paige made a really good point. If there's a negative in front of the x squared, this is still a parabola, but it's upside down. So it's not a U shape, it's an upside down U because of the negative in front of the x squared. However, that's one good thing to note when looking at it. That, all right, this is an upside down parabola if it were graphed. Method number 2 is you could just still do a quadratic. And quadratic is not going to care about that negative. You just plug in the quadratic formula like you would normally to make sure that your a term is negative 1 and you'd be fine. But when solving it and factoring it, one thing we can do is we can technically just multiply both sides by -1. That's going to flip the sign to everything over here. So it becomes positive x squared minus 12x plus 36. And because you multiply both sides by -1, the right-hand side is still just 0. And now you're left with this quadratic, which algebraically will factor fine. Normally, it'll be easy. But just don't forget in your mind, well, because you multiply by -1, this is still an upside-down parabola, even though you're forcing the signs to be positive. So all really good points. And that's what I would do if I was presented with a -a² term. I just multiply by -1, which literally just flips the sign of everything. And then you could solve it like normal. But you just keep in the back of your mind, that was a negative quadratic, so it's an upside-down parabola rather than right side up. And that's all the algebra review. Definitely wanted to get some of that out of the way because it is going to come up with some of these things that we're going to be doing in geometry. And I think the AC method is really cool to get exposed to. Like I said, you're likely going to see that next year. I think it absolutely does come up next year. I think Ms. Keener does it a little differently than I do. I find this way easier, but whichever method you want to do, go for. But now we're going to jump into some of the geometry with some more of our rules. I know we only have about 7 minutes left, so I'll probably show us the rule, do a few easy examples, and then we'll pick it up pick it up tomorrow. All right, arc and angle measures, intersecting chords, secants, and tangents. So the very first one we're going to do are intersecting chords when they are found in a circle. So it says right off to the left-hand side, and if you can make out the meaning from the words, that's great. But it can be a little redundant, hard to read. Reading math definitions are not the easiest, but let's read it. It says if two secants or chords intersect inside of a circle, then the measure of the angle formed is equal to half the sum measures of the intercepted arcs. So what does that mean? Well, the angle, in this case angle 1, is equal to half of the sum, which the sum of arc AD and BC. Now, a few things to note. This is not a central angle. Remember, central angles have to come from the center. That is not on the center of the circle, so they're not central angles. So angle 1 is not congruent to arc AD. It is, in fact, it's probably going to be smaller than arc AD because it's shifted away from the center. It's closer to an inscribed angle in a way. But we can find it by taking the intercepted arcs, and basically the other side, it's vertical angle, on the other side, we can add them together. And I'm going to give myself some room because it is going to be a fraction for the equation. We're going to take arc AD, and you're going to add arc BC, and you're going to divide the whole thing by 2. And that will give you the measure of angle 1. And don't forget that angle 1 is the same thing over here. So notice the symmetry on where the intercepted arcs go through. We're not using any of this information going up and down. We could, though. If we wanted angle 2 and we had the right information, you could figure out either one of those angles using the same exact rule, except the intercepted arcs now change because angle 2 is in line with arc AB. So because it's in line with arc AB and arc DC, those are the two that you would use for that calculation. So that one would be arc AB plus arc DC divided by 2. So, because that's the rule, if I go back to something we did yesterday, if you looked at 3 and 4, you could probably start to infer why we were doing some of this algebra review. And look at that, it's divided by 2, but no surprise, because that's kind of how the setup is going to be for this geometric situation. And everything could be an expression. You're asked to solve for x and then plug in. You could get some messy expressions that look like this, and it's your job to set it up, then solve it, which is why we did all that algebra review yesterday. But before we jump into the more complicated algebra ones, we're just going to use the rule, in a straightforward manner. It says find the measure of angle AED. So look where it is first, because they could really jump around in these diagrams. You don't want to make any assumptions. So they want this angle right here, which are these angles right here. And notice the arcs they gave you, 45 and 109. Those are the proper ones that you would want. So the measure of angle AED is equal to the sum of the two corresponding arcs, the intercepted arcs, which is 45 degrees, plus 109 degrees, divided by 2. All the numbers and all the plug-in has been on the right side of the equation, so that's great. We can just add them up. So 45 plus 109 is going to be 154 divided by 2. And when we divide that by 2, we get 77 degrees, which is our answer. So both of these angles, because they're vertical, are 77 degrees. And then the very, this will be the last one because I only got a minute left. They want angle STR. So always be mindful of the thing you're looking for and what you're able to find. This is a good angle to find because look, it's intercepted arc 112. So that angle and that arc do correspond well, so you can directly calculate your answer. And you do have arc PQ, I guess PSQ, because it's a, nope, can't even call it that. Because it's a major arc, because it's greater than 180. But either way, we're using 186. So angle STR equals 186 degrees plus 112 degrees, and that's going to be divided by 2. We add those up together, we get 298. Divide that by 2, you get 149. So that's a good spot to end, I think. So we got a lot of algebra review in, and then we saw a new rule. And that rule is what we will be practicing probably all day tomorrow. We'll see more complicated versions of it and so forth, where we'll have a little bit more algebra. Oh, actually, no, it's only this page that does it, because then it jumps into 3 other rules. So there's a lot of different rules coming up tomorrow. But I know we'll see practice where there is, some algebra involved. Well, we'll start seeing some of those expressions and kind of why we practice all that stuff. So you can kind of see ahead. All right? But that's a good time to leave off. If you guys have any questions, let me know. And don't forget about that weekly.